All right, so now that you've learned about the history of the atom and how all of these different scientists figured out what makes up an atom, we're going to do a quick review. Okay, so this is kind of a Jimmy Neutron looking, I don't know if that dates me, but kind of the traditional, what people imagine an atom looks like. And for this unit specifically, we're going to assume that this is correct. We've got protons and neutrons in this nucleus. It's extremely packed, really a really dense nucleus of protons and neutrons. And then the electrons are on the outside of the nucleus. Well, we can say that they're orbiting around the nucleus just to make us feel a little bit better for right now at least. All right, so then we have our protons. So just a little bit of information about our protons. Our protons are positively charged, and they're in the nucleus, which is great. We knew that. And the other piece of information is that when we look at our periodic table, which I've got an example of one element here from the periodic table. When we look at the periodic table, the number on top, this whole number, that actually is called our atomic number. And it actually tells us how many protons we have. So helium, for example, has 2 protons. Fantastic. A neutron is also in the nucleus, but it is neutrally charged, meaning it has no charge. So one way that we can write each of these subatomic particles, you'll often see me write that a proton is P plus because it has a positive charge. A neutron is N naught or N0 because it has no charge. All right. And then finally, an electron, which is floating outside of the nucleus, is negatively charged. So the way that we represent an electron is E minus. All right. And now I need to just distinguish between this concept of mass number and then that 4.003 that you see that is also on the periodic table for every element. So if you think about protons and neutrons contribute to the mass of an atom. Electrons have mass, but it is insignificant. To say, if you imagine, if we were to count the mass of an electron, it would be like if I had an elephant, that is the mass of protons and neutrons, and I were to say, what is the mass of a fly that goes onto the elephant, right? It's insignificant, it's tiny, so we actually don't even consider it. So when I say, hey, what is the mass number, meaning the mass of an atom, one specific atom, it is simply, all you have to do is take the number of protons, and you add to that the number of neutrons. We ignore the number of electrons. Now, notice I was very specific in my wording. I said the mass of one atom. As we'll learn in this unit, atoms can actually have different numbers of neutrons. So for example here, if you look at helium, this mass is 4.003. So what that's telling us is that not all helium atoms have a mass number of 4. There are actually probably helium atoms that might also have a mass of 5. But what we did to get this 4.003 is we averaged all of the different mass numbers that are found for helium. So this number here is the average atomic mass. And you will actually learn how to calculate this later in this unit. But for right now, just know that the average atomic mass is the average of all of the different mass numbers that exist. And mass number is simply the number of protons and neutrons. All right, so I'm going to do 3 example problems with you, and then I'm going to have you do practice on your own. So when we look at this symbol here, okay, this number on top, that is my mass number. And remember, your mass number is your number of protons plus neutrons. Okay, the number on bottom, that is my atomic number, which is the same thing as my number of protons. So when I say how many protons does this element have, I give you it right there by telling you your atomic number. It's 7. Okay. Now, protons have a positive charge. So if nitrogen has 7 protons, and it has no charge, and I will show you in the next section when it does have a charge what happens, but assuming it has no charge, which I don't show here, then in order for those 7 protons to be canceled out, if I have 7 positive charges, I need 7 negative charges. So I have 7 electrons. Now, to determine the number of neutrons, what I have to do is I say, okay, I have a mass number of 14. So if I have a mass number of 14, I know that what contributes to that mass number is my number of protons, which is 7, plus my number of neutrons. So if I have 7 protons and a mass number of 14, that means I have to have 7 neutrons in order to get that mass number. And so math-wise, you can just subtract 7 from both sides, and that gives you 7. Okay, let's look at another example problem. I have 20 protons, so that's my atomic number, so that's going to go on bottom. I have 20 protons, 20 electrons, cool, same number, and I have 21 neutrons. So to find my mass number, remember my mass number is simply my number of protons, which is 20, plus my number of neutrons, which is 21. So my mass number, the number on top, is 41. Now, how the heck do I know what element I have? Well, I'm going to look at my periodic table, and the element that has that has an atomic number of 20 is calcium. So this is going to be calcium. Now, I cannot use mass number 41 to determine that it's calcium. We use atomic number to determine the identity of the substance or the atom. All right, one more. I've got 11 protons. That is my atomic number. I have 11 electrons. Awesome. And I have a mass number of 23. Okay, so if I have an atomic number of 11, I look at my periodic table, and Na, sodium, has an atomic number of 11. Now, to find my number of neutrons, my mass number is 23. So remember, I got 23 by taking my number of protons, 11, and adding that to my number of neutrons. So how many neutrons would that be? Well, if 11 of them are protons, to get 23, that means that 12 of them must be neutrons. And that's it. So keeping in mind that you need to use your atomic number to figure out the identity of the substance, and that the average atomic mass, which is on the periodic table, is not used to determine mass number. I would either have to tell you the number of neutrons, like I did here. I said, hey, you've got 21 neutrons and 20 protons, or I would need to give you the mass number. So try these on your own. And then a question I asked was, look at your answers. Do you notice any patterns? Right? So maybe what is always the same? What never changes? Write down what you think and we'll talk about it in class.